So I'll begin with my explanation, and this is my front end. It has been hosted on one EC2 instance using Apache server, and I have only put in some HTML pages like login.html and index.html for making the for connecting to the backends, and these instances hold nothing but HTML and CSS. So I'll go ahead and log in into the application, and the username and password is admin and admin, and I'll submit it. So this is my portal. It's made with the simple HTML and AngularJS. I haven't included any CSS or any modifications to the view. So these are my tenants: Binoy, Kaushik, Apurva and Harshit. Out of these, Harshit and Apurva are my primary tenants, and I've included two more guys for the extra credit. So I'll go ahead and select Binoy first, and when you select the tenant, then it shows the URL at which it would be routing the request. So it's going to route at testlb port 80, and I'll choose a file. I'll say test4 and I'll upload, and you can see that the file is this. You can see the details of the file here, and it's hitting the API backend, and now when the response comes back, this button becomes alive, and you can click it. You can view the diagram here. This is the diagram which has been generated by Binoy's implementation. So now I'll go ahead and mark Binoy, and I'll say 20. Is the solution complete? True. Comments. Good job. Did the solution pass your test case? True. Submit feedback, and you can see it has added remarks to the database. So Binoy is done. Now let's move ahead with other tenants. So I'll refresh my application, select Kaushik, choose the tenant, choose file, test4, upload, and the file is visible here again, and the response is back, so we can view it now. And this is the file which has been generated by Kaushik's implementation. So is the solution complete? Let's mark it as true. Comments, NA. Please provide some improvements for this solution. None. Any drawbacks? None. And I'll submit my feedback. Added remarks to the database. So in the future of this video, we'll go ahead and check the database if these remarks have been added or not. So I'll choose other tenant now. I'll refresh, choose Apurva, select tenant, and choose a file, test4, upload, and the file is visible here. View diagram is ready, and this is the diagram generated by Apurva. So let's giving marks. Let's say 57 and true. Nice job. And I'll submit the feedback. So it says added remarks to the database, and on the back end it connects with the database, forms a session, and submits the comments inside the database. So now I'll go ahead and test my fourth tenant as well. So that's Harshit. I'll select him. I'll choose a file, test4.zip, and I'll upload it. So it's uploading and creating the diagram, which is now generated. I'll go ahead and view the diagram. This is the diagram generated by Harshit's implementation, and I'll give him marks. Like I'll give him 87. Solution complete, false. Comments not available. Provide next challenge. Do better coding. So this is the challenge for Harshit. Submit feedback, and it has added remarks to the database. So all the tenants are working, and I'll refresh my application and log out. So we are back to the login page. I'll close this application, and now I'll close these images as well, and I'll move ahead to my database, RDS console. So this is my database, which is running inside the personal VPC, and this personal VPC contains two subnets, US West 2A and US West 2B. So let's see the subnets. This is the VPC personal, and these are the subnets: public subnet 2, public subnet 1, and these are in US West 2B and 2A. So let's go ahead and check out the database from within MySQL Workbench. So these are some previous entries which I did. It must be containing tenant underscore data is the table which holds all the data entries which has been received by the front end. And so this is the way I'm providing multi-tenancy for all my tenants. So record ID, tenant table is there, and rest 10 columns are dependent on the depending on the tenants, they vary. And for providing multi-tenancy, I've used the same approach that was taught to us in lab 5 multi-tenant data. So let's check if we can see some of the comments. So this is for Binoy, and let's see again. Okay, so Kaushik 75, good work done, nice job. I did one comment related to, yeah, this is Harshit. I wrote find it yourself for him and I gave him 50 marks. I gave 87 to Harshit, do better coding. This is a previous comment, so good one. This was given to Apurva. So as you can see, all the data is being received by these table when whatever the data being provided by the front end. And tenant underscore fields contains the fields which have been mapped to the tenant underscore data table. Tenant underscore table contains the tenant ID, table name, tenant table name, and tenant table description. So these are the 4 tables which are for the tenants, and these contains 4 common fields: ID, points, complete comments, and you can see all these 4 fields are common in all 4 of them, and rest of the fields they vary. So Apurva is having none other fields, and Binoy is having 1 extra field that's fast, and Kaushik is having improvements and drawbacks, and Harshit is having the challenge field. So you can give custom comments to all 4 of them. And for the purpose of this project, I haven't inserted data in these tables separately. I've only inserted data in the shade table to show multi-tenancy. So now we'll go ahead and check our EC2 configurations. So these are the instances Harshit, Apurva, Kaushik and Binoy which I used to create AMIs, and here are my AMIs. So Apurva AMI, Binoy AMI, Harshit AMI and Kaushik AMI. These are the 4 AMIs through which I've created my launch configurations. So these are my launch configurations, and these launch configurations have been used to form auto scaling groups. So as you can see, LC Harshit launch configuration Harshit, A test, Apurva test, Kaushik AS, K test, and that's for Binoy B test. And this is a separate one. So these are the auto scaling groups which I formed for these tenants, and these auto scaling groups, or I should say the launch configurations, have been attached with target groups. So I'll show you my target groups. So these are the 4 target groups which receive all requests, and each one of them is having 1 healthy target, and so you can see 1 healthy target in each one of them. Okay, so these are the target groups and each of them contain one healthy target, and I'll go and show you my load balancer now. So I've used application load balancer, which receives requests on port 80, 81, 82 and 83, and those 4 ports are attached, are listening, act as listeners, and they forward to separate target groups. So 80 is for Binoy, 81 is for Kaushik, 82 is for Harshit, and 83 is for Apurva. So this was my load balancer configuration, and I could have used path routing as well, but I decided to go ahead with port routing. I'll also show you my subnets. These are the subnets which are contained inside my personal VPC, and the subnets are in US West 2B and US West 2A. So now I've logged into Apurva's implementation, and I'll show you how my API works. So this is the API, and inside this method, the base method receives the post request, and it generates the image at the back end, and then the get image returns the get request on this endpoint returns the image back to the user. And this is how I've done the OR mapping, and that is separate in our connection file. And the challenge here for me was that I was forming a session from inside a session, so I had to bound the outer session with the inner session, the database session with the outer session, and that was pretty difficult for me. So that was all about my implementation, my AWS configuration, and my front end, and my data multi-tenancy. Thank you for watching this video, and